So this question we had done, and in this question, in first part, it is required in electron volt. So when you calculate, obviously you will calculate in joules because uh, the formula, if you apply it as 2.18 into 10 power minus 18, that will give you in joules. A photon of wavelength 4 into 10 power 7, lambda is given 4 into 10 power minus 7 meters, SI units. It strikes on metal. So this will, because this is striking on metal, this will give you E, SCY lambda. The work function E is given 2.13 electron volt converted to joules. Why joules? Because lambda we have used, either you calculate this one also, you convert this one into electron volt, then you can use it in electron volt, or you convert electron volt to joule. Because lambda we have used in meters, we will get sorry, answer in joule, E. So that's why we have converted this one also in joules. So the energy of the photon will be from here, but because you have to get in electron volt, you will divide it by 1.6020, whatever is given here. Okay.
Oh,
Yes.
so,
Then yes.
but can't we just convert the wavelength into nanometers and then replace HCY 1240?
No, that's not the standard way. You do all calculations in one unit system. One unit system means if you are using meter here, meter is the system, SI system, right? So if you are using meter, joule is SI system. You
But
don't
the
intermix. I know that a few teachers and also in guides, that's the way they have done. But never mix the units. Nanometer is not the SI unit. So don't mix the units. Yes,
so like, but like we can get directly the energy in EV by that. So that's what I was saying.
it's not about getting directly. It is about don't mix the units.
Okay,
For example, in simple case, if I ask you, speed is given by distance over time. So don't intermix. Distance has to be in meter, time has to be in second if we are talking about SI units. And after that, if it is asked, you will convert it into kilometers per hour. If it is asked in kilometers per hour, you will multiply by 18 by 5. Or if it is kilometers per hour to meter per second, you will multiply by 5 by 18. That's afterwards. But when you are applying the formula in a formula, never mix the units. Okay.
good.
Otherwise, in board examination, it will cost you heavily.
Okay, sir.
Because in board examination, they have specific formulas, specific steps. And if you use something which is not the convention, you will be penalized for that. So you divide it by this one because one electron volt is given 1.602 into 10 power minus 19. Hence, one joule will be 1 divided by 1.6020 into 10 power minus 19 electron volts. So you will get the energy in electron volts here. Then E naught sorry, is given 2.13 electron volt. Now, second is kinetic energy of the emission. Kinetic energy, E equals to E naught plus kinetic energy. Apply this formula, kinetic energy will be E minus E naught. Because both you have in electron volts, here also you have got in electron volts, here also you know it in electron volt. Just substitute the values and you will get kinetic energy in electron volt, not in joules. Now, when you apply it, the formula for the third one to get the velocity, that is kinetic energy equals to half mv square. Here, kinetic energy must be in joules because mass you will be using in kg and velocity you will get in meter per second. So kinetic energy must be in joules so that all are in SI unit and you don't make any mistake. So suppose you use here in electron volts, you get the value in electron volt. Don't use value here in electron volt. It must be in joule. So convert it into joules first by multiplying it by 1.6 into 10 power minus 19. So these type of questions are slightly confusing, but once you have done two such questions or the intermixing of units, interchanging of units, not intermixing, then it will be easy. Right? All these questions you have to do yourself. So for example, here I got it in electron volt. I got it in joules, then converted it into electron volts because it was asked in electron volt. This kinetic energy unit is not given, so it's up to me. I can mention it in electron volt or I can mention it in joules. But if I want to use this kinetic energy in calculation of velocity, I must convert it to joules. So kinetic energy in electron volt will be this much. And if I want to use it for calculation of velocity, I must convert it to electron volts to joule. Then I can use it in formula kinetic energy equals to half mv square. From here, I can get value of V in meter per second. Anything, if not clear, don't hesitate to ask. Next question. Electromagnetic radiation of wavelength is just sufficient to ionize sodium at. Calculate the ionization energy of sodium in kilojoules per mole. Now wavelength is given. And if this is just sufficient to ionize, it means it is equivalent to ionization energy. Whatever energy is associated with this wavelength will be ionization energy. You just need to make sure that your answer should be in kilojoules per mole. Okay. So for that, you will calculate the energy of 1 mole of electrons, not just one. So wavelength is given. This is lambda, 242 into 10 to the power minus 9. Before I move forward, mark your presence. Just write present in the chat box. So this energy is given of the radiation, okay, 242 nanometer, and that is for 1 electron. And we need for 1 mole because question asks us to calculate per mole, kilojoules per mole. So that's why we will include N here, that is Na, Avogadro number, to have the energy per mole. Otherwise, for 1 photon, 1 electron, h nu is the quantum. Substitute the values. This is Na for 1 mole, Hc by lambda. Make sure that you convert the lambda into meters. That is common mistake. That's why I am repeating. So you get the energy in joules per mole here. Because you calculated for 1 mole, you will get joules per mole. You need to convert it into kilojoules per mole. Now, students ask, what if they don't do this? They miss to do it. Okay? This question will appear in 2 marks, and if you do up to here, you will get 1.5 marks. You will lose 0.5 marks. Because there is a stepwise marking here. Next, a 25-watt bulb emits monochromatic yellow light of wavelength of 0.57 micrometer. Micrometer, it means you have to convert this wavelength to meter. Lambda is the wavelength. It is given as 0.57 micrometer, and micro is 10 to the power minus 6 meters. So it will be 0.57 into 10 to the power minus 6 meters.
So wouldn't it be better if we write it as 5.7 into 10 raised to power minus 7?
Yes, if it is the answer, then it will be good because you need to write in standard form. But within calculation, you can leave it as it is.
Okay.
The question is 25-watt bulb, and here is required quanta per second. It means we have done a similar question, if you remember, during the class,
Yes, sir.
because it is per second and power is also energy per second. So 25-watt is actually 25 joules per second.
Yes, sir. We have done such a good this type.
We have done this type of question. It means for us, value of energy is 25 joules because we have to get quanta per second. Energy known, lambda known. Calculate the rate of emission of quanta per second means we need to get number of h nu per second. That's what we need. Number of h. How do we solve it? We calculate it for one photon is this much. Number of photons will be total energy divided by energy of one photon. You will get the answer. Okay. However, this will also give you the correct answer if you write ET equals to N H nu. E total equals to NH nu, as I have told you earlier, because here ET and will be 25 and it will be N and H nu will be HC by lambda. So actually you will get E here. It is E. So what you get actually, you get N equals to total energy by energy of one photon. E is H nu is energy of one photon. So it will be actually 25 divided by whatever energy you have obtained here. So whether you use this formula directly or you say energy of one photon and then number of photons, it is same thing. Whichever way you do, you just need to write the steps. Yeah. So here E will be Hc by lambda, substitute the values and you need to get down. The mistakes usually I see where students do, this is the common mistakes. 10 power minus 6, they forget to convert it to micrometer or they don't know sometimes. Next question. Electrons are emitted with zero velocity from a metallic surface when it is exposed to radiation of wavelength 6800 angstrom. Wavelength of this radiation is 6800 angstrom. But the velocity here is zero. Means
It is a
kinetic
threshold.
energy is zero.
So we will directly get threshold energy.
Yes. Yes, correct. So if kinetic energy is zero, E equals to E naught plus kinetic energy gives us E is equal to E naught. Kinetic energy is zero because velocity is zero. So calculate the threshold frequency and work function. The threshold frequency and work function will be interrelated because threshold frequency is that frequency which is related to work function. Threshold frequency is nu naught. So because E is equal to E naught will be Hc by lambda. You need to just substitute the values. So E naught will be equal to E, and E is Hc by lambda here. H is 6.626 into 10 power minus 34, C is 3 into 10 power 8, lambda will be 6800 into 10 to the power minus 10 meters. Okay. Now related to this lambda, nu is equal to C by lambda, nu naught will be C by lambda naught. That is actually lambda naught here what you have. Okay. Substitute the values, get the value of threshold frequency. How you do it? Threshold wavelength will be 6800. Why it will be threshold wavelength? Because it is the wavelength which is just sufficient to eject the electron without zero velocity. So lambda is actually lambda naught. E is equal to E naught, lambda is equal to lambda naught. So that's why this is actually lambda naught. From here, you will calculate the threshold frequency. Threshold frequency will be C by lambda naught. Substitute the values. After that, work function is given by H nu naught.
Upon 1 point. So for work function, sir, we need to divide no, so by 1.6.
Come again, what you are saying?
Sir, no, sir, I got confused. Sir, I got confused with sir EV, sir. I was thinking we have to divide it by 1.6 into 10 to the power minus 19.
That is in joule because
Yes,
all
so that
units
is
are in electron.
electron volt. Yes, sir.
Instead of W naught, you might get E naught. Okay, so E naught, W naught, same thing. And
Yes, sir. Work function is the
W,
same.
same. Next
So,
question.
so it was the same as energy, na?
Yes, same as energy. Work
Okay.
function, work. So sometimes this symbol is used for energy. So you will see that now I have seen that in the new edition of NCRT, they have used E. Earlier they used W. And one more thing, what change I have observed in NCRT edition, which was released last year. In this chapter, uh, now they have omitted the part saying clockwise and anti-clockwise. If you remember in quantum mechanics model, we talked about that there are two electrons in an orbital and one is clockwise, the other one is anti-clockwise. The clockwise is represented as +1/2 and -1/2 anti-clockwise. Now in the whole chapter I searched, there is no word like clockwise and anti-clockwise. So they have omitted that part, deleted that part. Now they just say one spin is +half, the other spin is -half. In the latest edition. In previous edition, clockwise is there. But in latest edition, clockwise, anti-clockwise terms have been removed. Next question. What is the wavelength of light emitted when the electron in a hydrogen atom undergoes transition from an energy level n equals to 4 to energy level n equals to 2? Now this question, basically, I will show you the answer later on. But first, I'll ask a few students to tell me the related formula and the value of N1 and N2 out of 4 and 2, which will be N1, which will be N2, according to the formula. So first, I'm asking for answer from Gyanendra. Yes, Gyanendra, switch on your mic and tell me how you will address this problem.
Yes.
I have got 3 hands raised. Yash, Amir, Kavish, also Arjun, Atmandeep, Vedant. Those who are raising hands, I'll give them chance after Gyanendra. Yes, Gyanendra, tell me how to solve this problem. Okay, Pratham, Samad, Pratyush also. So next
Sir?
I'll ask, yes, Gyanendra.
Sir, sir, the frequency is given. So, sir, we can, sir, convert it, sir. That, sir, V is equal to 3.29.
Where is frequency given?
Sorry, sir. Sir, but sir, V is equal to, sir, 3.29. Now, sir, we can go like that, sir.
No.
So I think he's calculating V bar.
I know that. Yes, Vedant.
He is calculating the wavelength.
Can we use the Barmer series equation?
Vedant, yes.
So can we use the Barmer series equation?
Okay, tell me which one will be N1, which one will be N2. First, tell me the formula.
Sir, 1
for you.
upon lambda equals to that Rydberg's constant into 1 upon N2 I minus 1
Okay,
upon
what is
N2.
Rydberg constant?
So 6 point, sorry, sir, 1.097 into 10 is power minus 7 meter.
10 to the raised to the
Sir,
power.
sir,
Sir, may I-
N1 will be 2 and N2 will be 4.
But first you need to tell me formula. If you don't tell me formula, and if you write minus or plus, depending on that, N1 and N2 will change. In few books, plus is being used. In few books, has not been used at all. Okay. So, but your answer is correct. Okay, fine. Next, I'll give you chance. No, I'll give chance to yes, Kartike. Tell me what is the formula? What is the value of N1? What is the value of N2?
The value of n1 is 2 and n2 is 4. And the
Okay.
formula which we will be using in finding wave number is 1.097 into 10 to the power 7 multiplied by 1 upon n1 square minus 1 upon n2 square per meter.
Per meter. Correct. So you have to use the unit
Sir?
because yes, correct.
Sir, Ni won't be, sir, 4, sir, because RH would be in minus, sir, and Ni would be, sir, 4, no?
This is here we are talking about wavelength. So you will use the formula of wave number. In wave number, you will always use positive.
Yes, sir. Yes, sir,
N1
it is
will always be
small.
less than N2. So
Yes.
that's why I was looking for that you don't include negative there, and you know that N1 is equal to N2 in wave number. So wavelength has been asked. If wavelength has been asked, you will invariably use the formula of wave number. If you write in per centimeter, then it will be 109677 1 by n1 square minus 1 by n2 square. And n1 is always in this case less than n2 in case of wave number. Means n1 will be 2, n2 will be 4. If you are using in per meter, you will change these two 1.097 into 10 to the power 7. And then you will substitute the values. So if it is per centimeter, we will use here I have not written, that's why I have explained. N1 will always be less than N2 in case of wave number formula. So lambda will be 1 by nu bar, and you will get the answer. 486 into 10 power minus 9 meter or 486 nanometer. Next question. How much energy is required to ionize a hydrogen atom if the electron occupies n equals to 5 orbit? Second part, compare your answer with the ionization enthalpy of hydrogen. Quickly, I got 2 hands raised. I'll give chance to Yash Bedi. Yes, yes.
So here we can use the formula that E equal to minus 2.18 into 10 to the power 18 into upon
10 power, 10 power.
so 10 to the power minus 18. 2.18 into 10 to the power minus 18 upon n square.
Upon n square. Okay, fine. Because it is hydrogen atom, you don't need to use the atomic number. That's fine. Now, that's fine. And then you say that the difference will be, but you can directly use the formula of difference in energy. Yes, you will get the same answer. Both ways are correct. Okay, what you said. You calculate E5 and for ionization, okay, E infinity. So if this is in fifth orbit, and we have to send it to n equals to infinity, that is ionization from n equals to 5 to n equals to infinity. That is ionization. So there are two ways. Either you first calculate E5 and E infinity, and their difference will be energy required. Okay. E infinity minus E5 will be the energy required. Other way is that you directly use the formula delta E and you get the answer. So delta E equals to minus 2.18 into 10 power minus 18, 1 by N2 square minus 1 by N1 square, N1 is 5, N2 is infinity, substitute the values, get the answer. The energy has to be positive. Now, who will tell me why this energy is positive? Delta E, the difference in energy when we are talking about ionization, why this energy is positive? Okay, 3 hands raised, 4 till now. Pratham, Amir, Arjun. Yes. Okay. I'll give chance to Arjun this time. Yes, Arjun. Why this difference in energy is positive?
Sir, I think that, sir, in this question, the transition is made from the lower orbit to infinity orbit. So since it is like, sir, if since the electron is going from the lower orbit to higher orbit, so there will be gain of energy, sir. But sir, it will be negative. Sorry, sir.
Mhm. Okay. Next, I'll give chance to Amir.
Sir, it is a difference in energy. So, sir, difference is always expressed as positive.
No. Next, I'll give chance to Pratham.
Sir, I was also about to say the same thing, sir, that Ahmed said.
Okay. Next, the last one, Yash Bedi.
But I think because the electron is gaining energy, so the energy change is positive.
Basically, Arjun also gave me the correct answer. So your answer is correct. Arjun's answer was also correct, but in the last, I don't know why he got confused. Okay. I told you that whenever energy is given to the system, it is positive. You have to remember this convention. Whenever energy is given to the system, work done on the system, energy given to the system, or you say energy absorbed by the system. Here system is at, or work done on the system. It will always be positive in chemistry. Energy released or work done by the system. It will be negative. So here it is positive because to move into higher orbit from say from second to third, it, the electron will absorb energy. Electron will gain energy to move to higher orbit. So if it is absorption of energy, it has to be positive. So this is a validation check also, whether your answer is correct or not. In exam, in tests, you will check the sign of the difference in energy always in this way. Next is compare your answer with the ionization enthalpy of hydrogen atom. Now tell me, what will be the value of N1 and N2 here in this case? N1 and N2 for ionization enthalpy of hydrogen. What actually it means? Raise your hands. Okay. Others, I need answers from you. Okay, tell me, Tanishi, compare your answers for the ionization enthalpy of hydrogen atom. So for that, you need to calculate ionization enthalpy of hydrogen atom. How will you calculate that, Tanishi? Unmute your mic and tell me. If you don't know, tell me where the problem is. Okay. Ariman Pal, okay, tell me the answer. You have raised hand.
Like the ionization enthalpy is like how much required energy to take the electron out of its orbit.
Okay. So what will be N1? What will be N2?
Sir,
May I?
Okay,
Sir,
what
may
is the
I?
ground? What is the ground state of hydrogen? Where normally you will find the electron in hydrogen atom? Ariman,
sir, you will find it in the lowest energy level.
what is that?
Sir, will it be the first one?
It will be first one. Okay. So in ground state, hydrogen atom will be in first orbit. And for ionization, you have to send it to infinity. So this is ionization of hydrogen atom. Means where the electron is and you remove the electron from hydrogen atom. Normally the electron is in first shell, first orbit here. So apply this concept. For ionization, N1 is 1 and 2 is infinity. Again, apply the same formula. This. Okay. And 2 is infinity and 1 is 1. Again, positive 2.18. And you need to remember this value. A few values you need to remember. This is actually the Rydberg constant, 2.18 into 10 power minus 18, which is the energy required to remove the electron from hydrogen from its ground state. So for that, you got the energy for ionization of hydrogen. Hydrogen has electron in n equals to 1. If you move it to n equals to infinity, means out of atom, the energy required for this one is ionization energy. And it will be positive because you will provide the energy to the atom. Atom will absorb this energy, atom will gain this energy. Now, don't forget to answer this question. Compare your answer. To compare,
We'll find the ratio.
yes, good, good. Find the ratio. And which one is greater? This one is greater. So for that, you will write the ionization enthalpy of hydrogen atom divided by, or there is a better way when you solve an examination. Normally, instead of writing delta E, write it as delta E 5 to infinity and write it delta E 1 to infinity. This gives you the flexibility to calculate the ratio. Okay? So you will say hence ratio will be E 1 to infinity delta E to infinity divided by delta E 5 to infinity. So when you calculate that ratio, you will say that this much, whatever amount is there, you need to calculate that the ionization enthalpy is these many times the energy required to transfer electron from fifth to infinity. So don't forget to write the statement. Hence, the energy required. So the statement, last statement will be hence the energy required, or you can say ionization energy. Ionization energy of hydrogen is X times the energy required to ionize a hydrogen atom if electron is in fifth orbit. Remember, if I don't mention the orbit, ionization energy always means from its ground state. If nothing is mentioned, ionization enthalpy or ionization energy is always from ground state. What do I mean by that? For hydrogen, it will be 1. If I say ionization enthalpy for sodium, so sodium 11 will be 2, comma 8, comma 1. It means n equals to 3 is the ground state. The valence electron is in third orbit as per Bohr's model. So here n equals to 3 to n equals to infinity will be the ionization enthalpy if nothing is mentioned. That is something you have to remember.
Sir, is the ratio coming 25?
Hmm? Again?
Sir, is the ratio coming 25?
Yeah, it is
So 25 by
approximately.
1.
Yes, yes, approximately correct. Next. What is the maximum number of emission lines when the excited electron of a hydrogen atom in n equals to 6 drops to ground state? Who will tell me the formula?
May I?
Sir, may I?
Okay, Arjun, yes.
Sir, may I?
Yes, Arjun.
Sir, summation of N2 minus N1.
N2 minus N1. No, the formula emission lines is different. Okay.
Sir, may I say?
Yes, Pratham.
Sir, we'll use the formula N2 minus N1 into N2 minus N1 plus 1 by 2 here. Sir, so answer would be, sir, 5 into 6, 30 by 2, so 15.
Correct. Right.
So,
yes, yes.
So here, as it is the ground state, can we use the formula n minus 1 by 2 directly?
Absolutely, yes. If it is to ground state, you can use n minus 1 by 2. Okay, that's what I have used here in this case. But in general, you have n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. So the number of emission lines, if it is to ground state, are given by n minus 1 by 2. Substitute n as 6, and you will get answer as 15. In general, the formula is n2 minus n1 multiplied by n2 minus n1 plus 1 divided by 2. And you will get the same formula basically if you have n1 as 1, because ground state for hydrogen is 1. So that's why if you substitute here n1 as 1, you will get the same formula. Then n2 is n minus 1 divided by n minus 1 plus 1 divided by 2. This got cancelled. You got n minus 1 by 2. So if it is to ground state, I would suggest that you use this formula. If it is not ground state, say n equals to 7 to n equals to 3, then use this formula.
So the number of emission lines is 15.
Yes, number of emission lines in this case 15.
Sir, I had it out.
Yes. Okay.
Sir, what is N2 and N1?
N2, N1. Here, did you get this question? The question n equals to 6 to ground state, is that clear?
Yes.
Okay. Now you have n equals to 1, n equals to 2, 3, 4, 5. So 1, 2, 3, 4. So 1, 2, 3, 4, 5. So the question here is if n equals to 6 to here, then how many transition lines will be there, emission lines will be there. So this is one possibility. Another possibility is that it goes to this first and then from here to here. Another possibility, it goes to fifth first and then fifth to ground state. These are the possibilities, and number of lines we have calculated using this formula. But if the question is How many lines will be there if transition is only from 6 to 3? From 6 to 3. In that case, the possibility will be first direct to 3, and another possibility first to fifth, and then fifth to third, another possibility to fourth, and fourth to third. So in this case, this is N2 and this is N1.
Sir, it would be 6.
Yeah. So you apply the formula and get the answer. Yes. Another tricky ways, suppose you forget this formula and the question is objective type question or fill in the blanks or integer type question. Okay. You can still use this formula, just have the respective value. If it is 6 to 3, it is just similar to if you have the transition from 4 to 1. How? Because you subtract 2 from here, 2 from here. The transition number of lines will be same. Suppose I consider from 2, 4 to 1. Again, how many shell orbits you are considering? 1, 2, 3, 4. These many you are considering. And if you are from 6 to 3, how many? 1, 2, 3, 4. So difference is 4 labels only. So even then you can use the formula intelligently and you will get the same answer. Just shift it to 1. Shift this 6 to 3 by 2 labels towards the nucleus. So if you shift 6 to 3, it will be 4 to 1. And you can apply this formula, n equals to 4. That's up to you. But you need to
Excuse
remember, I
me,
would suggest you remember both the formulas. Yes.
sir. Sir, can we also use like summation of n2 minus n1?
Well, if you can directly use the formula, right? This is the way. How? What? Just elaborate what you are saying, Arjun.
Sir, I mean, sir, there is a formula, sir. One more formula for determining the emission line, sir. Sir, like here, n2 is 6 and n1 is 1. So, like, we can do 6 minus 1 as 5, and then we can write as summation of 5, which will be, sir, 5 plus 4 plus 3 plus 2 plus 1, sir, which will give us answer as 15.
Right. That is actually the. You say that is an expansion of this formula, nothing else. That is expansion of this formula. It is always better that you write this formula and do it in just one step. What you are saying is expansion of this formula only, nothing else. So I would suggest that you use the formula, substitute the values and can get the answer in maximum 2 steps instead of, writing multiple values. Yes, Yash.
I think so. I raised the hand for answer.
So in such questions, don't go into those details. Okay. Those details are used sometimes in JEE where comparison is done. So in comparison and those type of questions I'll do. And then that might be, even then I don't normally use, but it might be required that you can use that and it might save some time in that case only. But here don't apply that. Okay. Expansion is not required at all here. Otherwise you are spending more time than required. Next, the energy associated with the first orbit in the hydrogen atom is this much. What is the energy associated with the fifth orbit? Who will tell me the answer? read the question carefully. By now, you should be able to answer these questions very easily. This is very, very easy question. So try to get the question. If you get the question, you will get the answer. If you are not getting the answer, it means you are not reading the question carefully. Energy associated with the fifth orbit in the hydrogen atom. First orbit in the hydrogen atom is this much. What is the energy associated with the fifth orbit? We have done a similar question. Okay, Amir, yes, have raised hands. Okay, yes, Amir, tell me the answer.
Minus 2.18 into 10 raised to the minus 18 by 5 square.
By 5. Okay.
By 5
So
square.
you need to first mention the formula. Okay. So you will first mention the formula. That energy will be energy of first orbital multiplied by z square by n square. Here it is 1. So you can write just 1 by n square. You skip this one. But first you have to write the formula, substitute the values, get the answer. Okay. Now, why this is important that you write it in this first form? Because in few questions, they will deliberately change this value. It has to be minus 2.18 into 10 power minus 18. But in few questions, you will see that they will deliberately change this value, and still students use minus 2.18 into 10 power minus 18 because they think that this formula has Rydberg constant as minus 2.18 into 10 power minus 18. Okay. So that's sometimes a mistake. So here I am not using it as Rydberg constant. I am using whatever is given here in all such questions. If the value is given for the first orbit, that is actually the Rydberg constant. So what is Rydberg constant in this case? This is RH. And what is RH? RH is energy of electron of hydrogen atom in its ground state. The Rydberg constant in this particular formula is the energy of electron of hydrogen atom in its ground state. Why? Because Z is 1, N is 1. So this is actually just 1. So whatever you get is the energy in first orbit. Next part. Calculate the radius of Bohr's fifth orbit for hydrogen atom. In this case, remember, we have used 5. Okay. I was explaining Rydberg constant. That's why I said 1. Don't get confused that here I would put 1. Here it is 5. Calculate the radius of Bohr's fifth orbit for hydrogen atom. 5 hands raised.
Sir, we'll use formula n square a naught by z.
Okay, fine. Hold on. Laksh Tomar, yes.
Yes, sir. Sir, we know the radius of both nth orbit is, sir, we can take it as, sir, 0.052.
Then what is the unit? You need to tell me the unit.
Sir, nanometer.
Okay, fine. And after that, 0.052. What is the formula? Complete formula.
And sir, then we can multiply it by 5 square.
Okay, right. So you need to just know the formula, and you said by 5 square. It is actually multiplication, not division.
No, sir, I didn't say divide, sir. I said we can multiply it by 5 square.
Good.
Sir, I didn't say n, sir, I missed it.
Then good. Okay. Now, if I say Here 0.529, it is angstrom. If I say 0.0529, it is nanometer. If I say 52.9, it is picometer.
Yes, sir, got it.
These things you have to remember. So whenever you use this value, make sure that you are using correct units.
Yes, sir,
In
I
these
will learn.
chapters, units are very important. So substitute the value and get the answer. Okay.
Yes, sir.
Next question. Calculate the wave number for the longest wavelength transition in the Balmer series of atomic hydrogen. Very quickly, I have got 3 hands raised. Okay. Don't answer. I'll, okay. Unless I ask you. If you want to answer, you can raise hand. This time I am not going to ask those students who have raised hand. Yash, Laks, Amir, Arjun, Pratham, Kartike have raised hands. Okay. I'm going to ask Arna. Yes, Arna. Tell me which values of N1 and N2 you will use. I'm shortly planning a Viva on this chapter. Okay. So tomorrow you need to do all the revision. Viva can be, in the next class, or maybe I can schedule another extra class for. So be prepared for Viva, do all the questions. Yes, Arna.
So we'll use Balmer series n equal to 2.
Okay. And N2? This is something I emphasized during the class, that for the longest transition, longest wavelength transition, what will be N2? Is still only 6 hands raised. It means you have not even seen the recordings. Okay, Shivani has answered. In the chat window, just raise your hand, right? So that I can know who needs more help or who is doing good. Okay. Okay. Good. So many hands raised now. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 15.
Sir,
So many hands raised. Let me give chance to Pratyush. Yes, Pratyush. What will be the value of
Sir,
N2?
am I audible?
Come again.
Sir, am I audible?
Yes, you are audible. Keep your mic
Sir,
switched on.
one upon the
Pratyush,
Redbox constant, 1 upon.
tell me just the values of N1 and N2. I am getting answers on the chat window. So
Sir,
many correct
N1
answers.
is N1 is 2 and N1 is 2 is N2 is 3.
Into 3. Okay, correct. So for the longest wavelength transition, the value of N2 will be just next orbit, just next of the series. So because it is Balmer, just next will be 3. And apply the formula. Get an answer. Because here I am using 109677. This will be per centimeter. Here I have used 1.097 into 10 power 7. That's why per meter. These type of questions will appear in your examination. It's not too tough if you understand the questions. Next question. Before I move forward, if there is any confusion, any query, you can ask. And my question to you, so many correct answers I have got in chat window. Okay. I think 15, 16 or more than that correct answers I have received in chat window. You can raise your hand, right? Why you are so shy? If you have confidence, just raise your hand and tell the answer. Next question is, what is the energy in joules required to shift the electron of the hydrogen atom from first Bohr orbit to fifth Bohr orbit, and what is the wavelength of the light emitted when the electron returns to the ground state. Now, the first one you have done again and again from 1 to 5th. Just you need to tell me if I use the formula like this, if I am using formula like 15 1 by n2 square minus 1 by n1 square. Okay. What is n1? What is n2? You can tell me in the chat window. If you are so shy, then you can tell me in the chat window. Otherwise, you can raise hand. Two students only raise hand. Okay, Yash and Arjun. I'll give chance to Arjun. Yes, Arjun. In this formula, if I have written it as minus 2.18 into 10 power minus 18, what is n1? What is n2?
Sir, N2 is 5 and N1 is 1.
Correct. Good. So if you write formula like this, and I advise you that you use this formula with a negative sign, and here n2 minus n1. n1 in this case will be lower part from the initial n1
So we
initial.
can use the other formula as well, no, in which Rydberg constant is positive.
Yes, then in that case, this will be 1 by n1 square minus 1 by n2 square. This
Yes,
will
yes,
change, right?
yes.
But why I advise to use this formula? Because the reason is, and here even, I have just asked the question. The formula will be slightly different. I'll tell you why. In such type of questions, why minus should be used? Because the energy, when we talk about the energy, is negative. So if difference of energy you talk about, difference in energy will be E5 minus, for example, it is first to fifth, E5 minus E1. And if you write it like E5 minus E1, it will be minus 2.18 into 10 power minus 18, 1 by 5 square minus 2.18 into 10 power minus 18, 1 by 1 square, like this. Okay. So this minus remains there because energy inside the atom is less than the minimum energy possible as convention outside the atom. Outside the atom, the I convention, the minimum energy is 0. But inside atom, it is even less than that. That's why negative. So this is a convention that you use negative. However, if you use other way around positive and then you change this one, that is also correct. Now, why I said that you will not use this formula directly? Because in the question itself, it is given in ergs. So rather, instead of using this formula like this, you will write it in ergs, and then in the end, you will convert it to joules. You will not use the direct formula to get into joules. Remember, the question is asking you to calculate in joules. But the ground state energy is given as minus 2.18 into 10 power minus 11. So for that, you need to remember the conversion also. So here write 10 power minus 11, not 18. And instead of joule, this is another unit of energy. Okay. So 1 erg is equal to 10 to the power minus 7 joules. You need to remember this conversion because it is given in ergs, so that's why you have used it. So from here you will calculate the answer. Substitute n2 as 5, n1 as 1. You will get answer in ergs. Multiply that by 10 power minus 7 to get the answer in joule. So make sure that you write the formula for ergs, substitute the values. Once you get it in ergs, then multiply by 10 to the power minus 7 to convert it to joule. Any confusion, you can let me know.
No, sir.
The next part is, and what is the wavelength of the light emitted when the electron returns to ground state? When it returns to ground state, the energy will be just the same, but it will be released now. Delta E absolute value will be same. So whatever you have from n equals to 1 to n equals to 5, delta E, same energy will be released. So delta E absorbed, delta E here released. So if you need to calculate wavelength, you will use same energy. E equals to Sc by lambda. So you need to use same energy. S1 2.09 into 10 power minus 18 joules to calculate lambda. E is equal to Sc by lambda. From here lambda equals to Sc by E. Substitute the values, get answer. Because here it is very small value. That's why I have converted it into angstrom. If it is very small, you can mention in angstrom, you can mention in nanometer. And sometimes in question, it will be asked that mention the answer in particular units. So I hope everything is clear till here. Next question. The electron energy in hydrogen atom is given by this, and this is, you know, the formula you already know. Calculate the energy required to remove an electron completely from n equals to 2 orbit, means n1 is 2, n2 is infinity. To remove from second orbit. What is the longest wavelength of light in centimeter that can be used to cause this transition? Again, related to that one, the same energy you will use. So E infinity will be 0, because I told you that the energy outside atom is 0. And from this formula also, you will get it at 0. If you have substituted n equals to infinity, it will give you 0. And here n equals to 2, you get the answer. Then you will use this energy to calculate the wavelength as 3467 angstrom. So similar to the previous one. Okay. And now there is this question, and you need to send the answer to me quickly after the class. Calculate the wavelength of an electron moving with a velocity of 2.05 into 10 power 7 meter per second. I am giving you just a hint. Okay. I can give you just a hint. There is something, an equation given by de Broglie. De Broglie gave an equation which gives you a relationship between wavelength and velocity, and send me your solution on WhatsApp. Okay. Any confusion, any student, let me know. Any query, just unmute your mic and let me know. And don't forget to send the answer of this question to me.
So should we use the E is equals to V HV formula?
No. De Broglie's equation. De Broglie's equation you will use. Okay, I'm just showing that lambda equals to h by mv. You have to use and get the answer. Make sure that you are using the correct units.